Well, good day. Very excited to be here. I'm Andrew Shepard. I'm the Director of Unmanned Aerial Systems at Sinclair College in Dayton, Ohio. I'm also the Managing Editor of the Journal of Unmanned Aerial Systems. So keep that in mind. If anybody has a good article they'd like to submit, we're always looking. This is, happy to say, my fourth trip to Israel, so I always appreciate the warm welcome and very happy to be here. Also, like to acknowledge all the great support and collaboration that we've had from the Xholon Institute of Technology, from Simlot, working with also the Dayton Regional Israel Trade Alliance, Hadass Bor here in town. And as we're moving forward, I'll have a couple other call-out points. So you may not know it, but Dayton, Ohio, which is where we're from, is sister city to Xholon, and so that's been the case for about 20 years or so, give or take. And so that's a great collaboration. It's not the only reason that we're happy to partner here in town, but it certainly is a nice connection point. So. Well, thank you again for having us here as part of the sessions today. So I'll be speaking about live virtual constructive, and we'll just basically define what that is, and then we'll talk about some exercises that we've done, and then how that technology is being developed. Certainly leaning heavily on the capability and technology that's been developed by Simlot, and leveraging our unmanned aerial systems capabilities and crews in America. So quickly on Sinclair's vision, just to set a little bit of a baseline, Sinclair is the oldest public two-year college in the country, in America. So it was founded in 1887. So it's been a continuous operation since then. And we may start offering some applied bachelor degrees in the near term based on the state of Ohio's approval. But think of us as a large associate degree granting institution. We have about 32,000 students enrolled this last semester on the academic side, and another 15,000 students a year through our workforce training program. So we're a large institution, and Ohio is a larger state, so about 12 million people in the state. So we serve a good region. So related to UAS, we had a vision at the president's level, at our vice president's level, and then at the board of establishing a national center for UAS training and certification. That became a reality several years ago. And we won't be going through a large overview of the program today, but suffice to say that we have a two-year associate's degree, one-year certificates, one semester-length certificates, custom workforce training, and we're also a collaborator with federal-level agencies and academic programs around the country and the world. So we wanted a international leadership position in UAS, and that was both with our local partners. We're right next to Wright-Patterson Air Force Base, which is about 24,000 employees work on Wright-Patterson Air Force Base in Dayton. So it's a very large facility, and there's a lot of technology there. And also, we have a long history in aviation in Dayton. So most people may know this, but the Wright brothers who invented the airplane were from Dayton, Ohio. One of the first unmanned vehicles was from Dayton, Ohio. It was 1918. It was called the Kettering Bug, and it was a collaboration with Orville Wright and Charles Kettering. So we go all the way back 100 years. We're going to have a bunch of parties next year on UAVs. But as we're looking forward, it's definitely a partnership-driven approach. And so partnerships are the only way that complex activities like LVC can really occur in a cost-effective manner and advance the technology for everyone's betterment. So a little bit of background on live virtual constructive. So in broad definition, live stands for real participants operating real systems. And so I'll be pointing out some examples of that as we go through, but it could be a member of a ground search and rescue team on emergency response. It could be a real unmanned aircraft flying with a real operator. It could be a traditional aircraft with a pilot inside, or any number of other activities. Virtual are generally real participants engaged through simulated systems. And so you might be sitting at a computer operating in an immersive environment, and as you're sitting there working through the scenario, you're controlling a sensor feed, you're mission planning an aircraft, and that's adding to the capability. And then constructive are generally computer-generated entities that are part of the scenario. They might be feeding you information, but you're not generally in control of them during the exercise. Something to think about LVC is it's something that the United States military is focused on for several years now. Something that they've determined through their studies is that you can decrease the expense of a given activity by up to 40% while increasing safety and allowing more complex operations. So that was really why we were initially interested in it for civil applications of unmanned aerial systems. And so what we think we'll do is we got a quick video that we'll play here, and this will describe a little bit of it in greater depth, and then we'll go into some examples of what we've been doing. LVC stands for live, virtual, and constructive. And what each of those mean is live or real people doing real things in the real world. So you might be outside flying a real unmanned aircraft system with telemetry or its location and time and space coming down to your ground controller. You might be broadcasting a video feed. You might be walking around in the environment with a cell phone broadcasting your location. Virtual are where you have real people doing simulated things. So you might be sitting at a simulation station operating a sensor feed from a virtual aircraft. And then constructive might be computer-generated actors that you really aren't controlling, but they can provide information to the scenario. Those three feeds really get put into a scenario environment and they appear as if they're all happening at the same time together. Our interest in LVC is for civil applications, and so first responder applications, infrastructure inspections, beyond line of sight, concepts of operation development and things like that.
Sinclair's work in UAS, specifically around the live, virtual, and constructive, really helps to keep the region on the cutting edge of both UAS technology and UAS actual flight. So it's really an important piece of the puzzle in terms of how you establish, understand, and test potential commercial applications.
LVC is really attractive for training because it allows us to integrate more participants in a scenario more inexpensively. So you could have a lab of say 10 or up to 20 students sitting here in this simulator lab engaged with other students that are out in the field flying live aircraft. They could be connected to our mobile ground control vehicle, so you could have additional operators there. And in one of our prior exercises, we actually had participants connected to our LVC exercise participating live from Israel.
Every organization running a SimLab system can potentially participate in an LVC exercise. So not only making all those pieces play together, but also the application that they're playing on, like search and rescue, inspections, and other important civil applications.
With LVC, you're not just simulating the inputs to a flight controller and measuring its outputs, you're simulating the entire operational environment, vehicle, human, airspace, social, and other intangible measures that go into the complexity that is flying an aircraft in the national airspace system.
Working with Altavian and Simlot, we were able to develop a simulator for the ground control station of the Altavian's flight control system. And so you can sit in our simulator lab, in our mobile ground control vehicle, or anywhere that software is installed and run in simulator mode just as if you were sitting at the real ground control station, leveraging the Simlot software. So it's our plan in the future to be able to do that remotely, so you can log in through the internet and then be able to work through your ground planning and a lot of your con ops before you ever show up to the airplane, save you time on site and make it much more effective while you're there. Okay, so that's a little bit of review and some additional background. And so why we show that is that sometimes a picture is good, a video is better, right? So as you see, there's a lot going on there with not just unmanned aircraft operations, but also traditional aviation assets, ground team crews, both in the real world and in the virtual environment. So what we're going to talk about now is first, a review of our first LVC exercise. This was a technology development and basically proof of concept exercise in August of 2016. And you know, again, I can't stress enough the importance of Simlot in all of this. So that's really the technology that ties all of this together. So as we were looking to develop this initial scenario, we thought, well, first responder applications is very much a key to the application of UAS. It's something that communities will more readily accept, sometimes if they have concerns about security or privacy. It's also needed, right? You have missing persons, you have disasters that happen. And so we decided to focus on that first. The facility that we were flying at, I'll describe in a bit more detail, but that's the National Center for Medical Readiness, also located near Dayton. And that's a kind of a disaster training facility. So there's a simulated, it's a real airplane, but it's a simulated crashed aircraft. There's ground vehicles, they can flood a city, they can flood some cars, things like that. We have our mobile ground control station, which you see there, and then our simulation lab, and then connected over here to Simlot's office in Israel. We had participants here in country. So this hypothetical scenario took place with the idea of a tornado touching down somewhere in Ohio. Tornadoes unfortunately happen quite a bit in the Midwest, so actually since we've been here there were 72 tornadoes that touched down in Ohio. So it's not uncommon. So we said, okay, that's a reasonable scenario. The idea was focused on search and rescue in a disaster relief operation. And then we had our participants, which were really students that we engaged through a contractor, that they were able to come in, be paid for their involvement, but they also got to participate. And they were acting as emergency response services, law enforcement, search and rescue teams, and the Red Cross. So the components of this exercise were we had the live assets. So remember, those are real entities. So we had a Lockheed Martin Indigo. It's an unmanned aircraft system that Lockheed makes that allows you to transmit down both electro-optical or visual spectrum video and infrared. We also had the ground teams, which had cell phones that had a special app that would allow them to transmit their location, basically telemetry from the cell phone, and we could track them in the scenarios. We had virtual systems in this scenario, so we had virtual fixed-wing aircraft, unmanned. We had Altavians and then generic systems, and then we also had operators back at our campus and then over here in Israel. And then we had constructive entities that the simulator was generating that were feeding information in the environment, but we weren't necessarily controlling those. So missing persons, ground vehicles, first responders. So this is kind of an architecture view of what we're talking about. So Dayton was serving as the hub in downtown. And so we had our Nova 1 and Nova 2 Altavian aircraft. The iOS is kind of the hub of how all this connects together. Over in Israel, we had a simulation component. And then in the field, we actually deployed our mobile ground control vehicle with simulation capability and then the live feeds. An easier way to look at that is perhaps this more visually. So downlink video and telemetry from the aircraft, going through the mobile ground control station with the simulators to the National Center for Medical Readiness, which went through the Ohio intranet, which is a fiber optic network dedicated off the internet in Ohio, to our facility in Dayton, cellular telemetry coming in, and then a two-way communication to Simlot. So those were the pieces. That's a fairly ambitious initial activity. So we had a lot of connection points, and it was international. So NCMR is, as I mentioned, is a realistic training environment. The top image here, this used to be a cement factory. So back in the 1920s, they built this facility. That's about a 150-foot tall cement tower. What's interesting about the facility, it's 53 acres, but it sits in what's called controlled airspace. It's actually in the air traffic control area of Wright-Patterson Air Force Base. So we had to get special permission from the Federal Aviation Administration and from Wright-Patterson Air Force Base, along with the property owner, which is Wright State University, to allow our activity to occur there. So that in itself was a process, but that was good. And then you see an outline of the facility. Basically, it allows you to emulate disasters like this at an inexpensive cost in a dedicated site. So what we did is we divided the area up into operational zones. So you have different parts of the scenario. We broke it really into two halves of the day. And so in Zone D, in one part of the day, might be a missing person. In Zone C, we might have a first responder staging area. The Indigo was flying up here in the center of the facility. We had a fairly large buffer to the property lines for safety reasons. But the video and telemetry was coming down from the aircraft. Here's kind of how you might break that up. So in one of the scenarios, firefighter deployment here, Red Cross here, EMS there. So what's happening back in the UAS center is I've got each of the screens labeled. And so what you can see here is this is kind of the top-down view of the scenario. This is coming out of the Simlot software. And so you can see that the facility has the terrain, or the DTED. It has a high-resolution map overlay. You can see in this screen we actually had 3D models of the facility. The facility was recreated in 3 dimension, and so you can see the vehicles and things moving around in that space as well. The entities that are operating in the center, it's a little hard to see, but you can see some of them might look like a person on an icon, some of them might look like a vehicle. So as those are moving around, you can track them from a map view. To the right, you've got the video feed actually from the unmanned aircraft. So this is a live video feed that was coming down from the Indigo as it was flying, and that would also show up on a map of where it was in the environment. The lower left is the video feed from the virtual system being operated from our mobile ground control vehicle that was at the site. So you had operators there flying virtual systems as well. And this is coming in from Israel. So this was a virtual system being operated here in Simlot's headquarters. This is our UAS simulation lab. It's about 800 square feet of a 28,000 square foot facility that's dedicated to unmanned aerial systems and aviation programs at Sinclair. Plus we have a few other facilities, but kind of gives you a shot of the room, and so all these stations were connected with video feed or engagement. So here we have the Altavian F-7200. This is about a 6-foot wingspan aircraft that we really fly and operate in the National Airspace System. Basically at NICMR, it's too small to fly a fixed wing there with the airspace approval that we had, so we flew them virtually. And so what you can see is the aircraft has a flight pattern that it was flying in the simulator that you heard about in the video that was developed working with Altavian and Simlot. So this is a perfect representation of the ground control station as it would really exist if you were flying the aircraft in real life. And believe it or not, up here in this top image, that is a screenshot from the virtual National Center for Medical Readiness that was in the system. So that's the 3D rendering of the building. That's a 3D model of the aircraft flying by. And so that's basically what you would see if you were really there as the operator or the visual observer with the aircraft flying by on the ground. So those are being operated from these two seats here. Here in Israel, as I mentioned, all the screens are shareable during these exercises. So they had a video feed of our Indigo. Here you've got an infrared downlink, and the virtual systems that were being operated from the site. And there's Hadass and Yanni, so they were working on it. Here's our mobile ground control station. So this is a custom-built vehicle. We actually had this retrofitted from an ambulance, and we have an instructor or a chief pilot and then 2 junior pilot or student stations in it. There's 11 screens inside. It's got a 12-day high-definition video storage capacity, an hour battery backup, a generator, shore power connection. It's got air conditioner, that's important. But you can mount monitors on the outside and operate it either aircraft or virtually from this system. So it's the initial development by that company was this vehicle. So that was deployed to the site. Here's the Indigo. So this is the vehicle that was providing that video downlink and telemetry. So you can see that was a live operation. And then this is the live and virtual sensor feed. So this is the video feed coming down from the Indigo, and here you can actually see where the Indigo is in space in the simulation or the virtual environment, and you can see that visual footprint actually matches up to what you see in the video downlink. So they align in the scenario. And I should mention that that Red Cross tent was virtual, so we didn't have to recreate everything. So video feeds from the Indigo. On the left, you got the EO video. On the right, you have infrared. In this case, black is hot. So as our search team was going through, you could track them. And this is kind of to show you. There's our missing person. So they're showing up on our infrared video feed. As the crew would see it from the aircraft on the video feed, they could radio to the participants that were off on the search teams and tell them which direction to go, and as they were getting closer, radio them through. And we can view all this back in Dayton. We can view it here in Israel. It's all live and integrated. So victim recovery, I will say that these participants that were in the victim recovery, these are unmanned systems and traditional aviation pilots. So I don't think they were holding the neck very well. You see like arms kind of swinging off the gurneys as they carry them by. But you know, it was a good exercise. So we were able to go through the entire recovery effort. So a lot of firsts. Okay, so what was this? This was the first known international civil UAV LVC exercise. So that's kind of a mouthful, but you know, the companies that were doing this before often were defense focused, and it was very expensive to be able to pull off an activity like this. And so working with Simlot, we were able to get this down into a very nice capability that really I think exceeds a lot of the more expensive existing defense products, and also it's got a civil focus. It was the first time we had Simlot systems as part of a civil UAS. It was the first time Simlot was incorporated in multiple sites like that. So we had our mobile vehicle, our simulation lab, and here in Israel. First integration of a Lockheed Martin. We actually had to work with Lockheed on getting the telemetry and everything unlocked so it could be ingested into the scenario, which was another thing because of international regulations on sharing that data. First time we integrated an Altavian simulated, and it was first UAS flights for LVC at NICMR. So a lot of stuff going on. So that was pretty ambitious for our first activity. Before we move on to the second activity, I want to be sure that we acknowledge the collaborative nature of our work with the Dayton Region Israel Trade Alliance. For those that don't know, our region actually has an employee that works full-time here in Israel and helps us make collaborations like this possible. So a lot of advocacy, investment, even some of the funding that helped pay for this initial activity came through Montgomery County and in Ohio. So that was a great work. And so here's kind of the shot of the team, that was here in Israel as part of the exercise as we were doing the live event. So definitely appreciate all that help. So that laid the foundation for our second exercise that I'm going to highlight here. So this is beyond visual line of sight. Beyond visual line of sight is kind of a big deal because in America, there are regulations now that allow small UAS operations in the national airspace system. But one of the requirements is that the operator has to maintain visual line of sight, or you have to be able to see the aircraft at all times during the flight. Well, that's pretty prohibitive if you think about it. I mean, there's a lot you can do with that, but say you're doing a power line or a road, any kind of line target, we would call it. You don't want to have to take off and land every time you fly as far as you can see the airplane. So this is something that the Federal Aviation Administration, our governing body of air regulations, is interested in being able to allow us to expand. So what we wanted to show is that you can use this technology to develop and test concepts of operations, or the ways that you should be able to implement this in a safe and cost-effective manner before actually going off and spending a ton of time and effort on something that may not pan out. So again, we partnered with Simlot, and in this case, Drexel University, which is located in Philadelphia, Pennsylvania. In this case, we had our simulation lab again as the hub. We integrated live aircraft, manned aircraft this time. So we had 2 manned aircraft. Mobile ground control station was integrated with Simlot again, and then Drexel was plugged in. And the nice thing about Drexel is we had actually trained the pilots at a company called Keystone Aerial Surveying to fly the Altavian aircraft about 3 years ago. And so they came to Drexel and operated the virtual systems as an industry partner in Pennsylvania during the exercise. So that was another nice time. They do a lot of flying for the Army Corps of Engineers. So LVC this time, we had our live two-manned aircraft. Jeff Miller, who will be speaking here in a moment, actually got to fly in one of the aircraft as part of the exercise, so I was a little jealous. We had our fixed-wing integration. So this was our first live asset Altavian. And both of those had ADSB, it's called Automatic Dependent Broadcast Surveillance equipment. So they're basically broadcasting their position in space through an air traffic control network, and we have antennas that can pick that up. And so instead of just getting the radio signal off the aircraft like you might otherwise do, they were actually in the National Airspace System broadcasting their location. So we also flew the Lockheed Martin Indigo again with the traditional downlink telemetry and the video feed. Virtually, we had 2 stations in our mobile ground control system, or the truck. We had 2 stations in our simulation lab, and then we had the station in Drexel, and then again, constructive manned, unmanned aircraft. And we also were ingesting non-participants. So in this scenario, we actually could pull in aircraft that weren't part of our scenario because they were also broadcasting their in space and visualize them as well. So in those cases, if they were going to be in conflict even with one of our virtual aircraft, we would divert our virtual aircraft even though they really weren't both in the same space in the real world. We were acting as though they were. That's kind of the beauty of being able to do something like this. This is an eye chart, but that's the architecture. It gets a little bit more complicated every time we do this, so more pieces, more connection points, more colors. So to make it a little bit easier to follow, you've got your image here again. So you have 2 manned aircraft, 2 fixed wing, your Indigo, downlinking through the city of Springfield to our national center, and then connecting 2-way to Drexel. So those are the components. Kind of a shot out at the airfield of how that all goes together. So a lot more moving parts this time. We also engaged our traditional pilot flight training program. So we actually were using aircraft that we use when we're training airline pilots, and they were integrated into the scenario as well. So manned aircraft 1, this is actually a aerobatic aircraft. So there's Jeff in the back, Ryan Smith's in the front. Ryan does a lot of work with us. He's actually a former U.S. Air Force test pilot. He's a Boeing test pilot, and he also was a French test pilot. So he's a good guy to have on these kinds of projects. Aircraft 2 is our trainer aircraft for the flight school. So they were both part of our scenario. Okay, so you saw the Indigo before. This is the Altavian doing its pre-flight check. So you have to check all the accelerometers and all the instruments are working correctly. The flight controls are moving before you launch. This is from the back of the mobile ground control station. So you've got a virtual operator in here, and they've got screens that are giving them all those feeds, just like if you were in the simulation lab out in the field. Here you've got your virtual ground control station and VO view for the Nova, and then the traditional Simlot impact stations. Kind of got that top-down view. Now, this is a much larger operating environment, right? So the last time, the first exercise, we were basically operating in 53 acres, which I don't know what that is in hectares, but it's small, right? This time we're operating in multiple square miles, maybe about 10 square miles of territory for this exercise, right? So here we've got Ellen, Dr. Bass, and our Keystone pilot over in Pennsylvania. And here's kind of those shots again. So you can see a much larger area that we're operating in. We had 3D views of the airspace as well. So basically, aircraft that are in green are aircraft that we're basically getting ingest from. The aircraft in blue might be Constructive. So you see down here, you got your vertical takeoff and landing Indigo. We've got our Altavians, and everything's integrated into the same environment. So a couple notable accomplishments. And first, again, this was the first known LVC implementation for beyond visual line of sight. This was a lot of interest to the Federal Aviation Administration. There's definitely a potential being able to use this as we're going forward in the integration of unmanned aircraft into the national airspace for beyond line of sight. It also supporting the United States Air Force. The Air Force and the state of Ohio have paid to put in a ground radar network just outside of Dayton that can be used for testing this kind of equipment. And so they're very excited about the idea of being able to record and visualize scenarios like this in a way that can be viewed remotely during exercises and recorded, played back, and analyzed. It also was the integration of multiple live and unmanned assets. So to my knowledge, that hadn't been done outside of the United States Air Force to that point, right? So that's kind of a big deal. The people at the Air Force base were a little surprised that we were able to do that. So that's good. We had, again, multiple sites, and it was supporting that collaboration. So again, a lot of thanks to Simlot. So as we're looking at moving forward, since that event, we actually did a live demonstration at the, it's called United States Geospatial Intelligence Foundation Geospatial Intelligence Conference, right? So it's a little bit of a mouthful, but think about mapping and aerial imagery and that type of thing. We did a live demo for about 660 people at their conference in San Antonio, and we had our mobile vehicle down there on the showroom floor with operators in the vehicle connected back to traditional manned and unmanned aircraft systems flying at Springfield Airport, virtual systems at Sinclair, and we were able to do an hour-long demonstration of beyond visual line of sight during that show. So that was a little bit of stress, but it all worked. So now we're ready to expand and start leveraging this as not just a training capability, which it is, but also an ability, as I mentioned, to develop what are called the concepts of operations, the safety risk mitigations, and the technology integrations that are going to be required for safe UAS deployment, not just in America, but really globally. So it's our hope to continue to collaborate with not just Simlot, they're key to this, but also with the Institute here. So we're very happy to give you that overview. Hopefully it was interesting. I know there's a lot of stuff and moving parts in there, but I think that's a great acknowledgement of the partnership between our two communities and our two countries. So thank you.